In this video, I want to compare the planning capabilities of Claude Sonnet 4.6 model with those of the Opus 4.7 model, because I want to gain a better understanding of how Claude plans the features before implementing them. However, pay attention, I will never in this video say anything like Claude's planning engine or something like that, because there is really no such thing as a planning engine in Claude. It's a trick. We will touch on that, we will have to cover that as well before we can understand how Claude plans the features. So let's begin and we will get to that question too. I will first start Claude Code, but not just start it. I want to start it with auto memory disabled, because I don't want any previous runs to affect what I'm going to show you. And here we are using Claude Sonnet 4.6. I'm quickly initializing Claude.md. I have set the basic instructions in the background. You don't have to bother with that. So I'm starting the new session and the prompt begins here. Let the user upload a source code directory on the web application. I'm intentionally using a non-standard demo because I want to see Claude coping with that. Some directories should naturally be ignored, like directories with binaries or node modules. A word about storage: just write the files into one JSON document on the server for demonstration purposes. And then rendering, check if the JSON file is present. If so, then display a table with each file's path, name and the number of lines. Otherwise, display the directory upload controls. And here comes the principal idea of this demo. I want Claude to generate a plan, which I will review. And you can never say this too many times to Claude: don't change anything. Moving it to plan mode and running. Some time will pass and we will have the plan ready, so let's review it. At the beginning it is the program.cs explained. There's nothing interesting here for me. Now this is interesting. The server-side implementation. I see it plans for removal of ephemeral directories. That looks correct. You must repeat all logic on the server, for security reasons at least. But I didn't see a corresponding logic on the client. And that begins to worry me already. So when I let Claude implement that plan, this is what I got. Remember, this is Claude Sonnet 4.6. The post action on the server looks right. There is that directory filtering. There is the counting of lines and collecting the data for the remaining files. But again, the front end is what worries me. This is table rendering. That looks right. But uploading the directory is just a bare input element. This is precisely what I feared I will find when I saw that plan. There is no filtering on the client. So the problem is that somebody could upload thousands of binary files to the server only for the server to throw all those files away. That is not acceptable. That is a wasteful implementation. Not to mention that it puts the server in danger, because too large directories will make the server fail instead of just skipping the entire upload. How could this happen? Tell me. How could Claude not plan for client-side filtering? That is common knowledge. Well, that brings us to the question of planning and the planning engine, which doesn't really exist in Claude Code. The plan is just the result of another prompt that was carefully crafted and wrapped into a sandbox to avoid any modifications to the underlying source. A real planning engine would require at least symbolic logic. That's what we humans do. But Claude is powered by an LLM, and LLM is powered by a deep neural network. There's no planning there, it's just pattern recognition. We had planning mode in ChatGPT 2 or 3 years ago. This was very simple. You would craft a prompt that says, now that I told you all I need, now do not give me the implementation, but instead give me a numbered list of steps that I need to make to implement this. And it would spit a numbered list out and it was looking like a plan. That is precisely what Claude Code is doing under the hood. It is much more capable than most of us were when doing that manually, because some people who know those things, who know prompting better than I do, would create a better prompt that would eventually come up with a better looking plan. But that plan will not be more correct. That is the problem. And we can see that problem all around. Let me show you the code again. This is another trait of planning mode as it is implemented today using LLMs. There is no depth of thought. We had the entire file on the server, and yet the server is throwing all the content away just to store the lines count. Why? Because that is what requirements said. But we humans, we know better than that. We would call the customer and say, hey, are you sure you want to throw the user's data away? Maybe you will need them for the next feature you will plan in a month. You see, LLMs do not have that thinking process we have. And the worst is yet to come. I'm running the application, uploading the directory with this demo implementation, and when the page refreshes, you will see the file paths are lost. The implementation has put file name in both fields. That is a serious blunder. The bottom line is that Claude Sonnet 4.6 did not suffice in making a sound plan, and even after creating whatever plan it made, it failed to implement it, which makes it look even more pitiful. Among us, I have stopped using Claude Sonnet entirely some time ago. It has a high bug rate and endemic stupidity that made me start avoiding it completely. This front-end code is the epitome of incompetence we see whenever we ask Claude Sonnet to develop anything on its own. This ends the trial of Claude Sonnet. I will start all over again from the initial code, this time using Opus 4.7 model. I want to see how it behaves. I want to see it behaving differently. The prompt will be the same, but the model should be more thoughtful this time. Planning mode is on, and off we go. I have great expectations from this run. While Claude is working, let me use your presence to ask you for a favor. You know that this YouTube channel and everything on it is free for everybody, but the secret is that it's only free thanks to the patrons, the people who are sponsoring this channel. Running a channel is an expensive exercise, and so I would be grateful if you would consider joining the community of patrons on my Patreon page. As a sponsor, you will have access to the source code of this video and all other videos on my channel, as well as some discounts and offers I occasionally post there. Thank you very much. I'm really grateful to all the people who are helping me maintain this channel. Now, in the meanwhile, the planning is over, and let's review the plan now. At first glance, Claude Opus has created a much more detailed plan. It planned for a more diversified model that will pull this feature. That's fine. And here comes the critical difference. Claude Opus has planned for client-side filtering. I wanted to see that. And that brings us back to the question of the planning engine, which again does not exist as a separate engine. The plan, both in Sonnet and Opus, is the result of one or multiple prompts that were passed to the underlying LLM, and this is the result. Opus makes a much better plan because it is refining it in multiple iterations. It will still have some blind spots, but most of the blind spots of the Sonnet planning will be gone. That is a very good thing. Sometimes Opus looks like it really plans things. That's the funny thing. Anyway, by carefully prompting the LLM and doing that in multiple iterations, Opus is capable of creating a sound plan that avoids most of the pitfalls. Now, the point is in carefully crafted prompts. I cannot even imagine what's part of that prompt, but it's obviously that Opus is making a step up from a medium-level programmer based on all that average quality code that was used in training of the underlying LLM, is making a step up by steering the answer of the LLM towards a more senior level content. And that is what actually makes the Opus plans good. It's not that there is some symbolic logic under, some better understanding, some knowledge of programming. No, it doesn't exist. The point is that Opus is operating on an LLM in a much better, more costly, but much better way. So we see the results. I have instructed Claude Opus to implement this plan, and we can review the results. Straight to front end, there's a lot of JavaScript code here that is good. All this was missing in code that Sonnet generated. All files belonging in ephemeral directories are filtered out on the client. That is excellent. There is also code that repopulates file paths that were stripped off by the browser, so Opus didn't make that awful bug the Sonnet made. As the result, I really expect this version to work just right. I'm uploading the directory with this demo's source code, and here it is. All the paths look right, and all the names look right too. Let's see the JSON file on the server then. It has the same structure as that created by Claude Sonnet, but file paths are correct this time, there's no bug. Though there is still this detail that tells me how heartless and soulless the code can be when written by common AI. All the precious users' personal data we had are lost again. How shall we beat the competition if we lose the opportunity to spy on our users? Server implementation is also correct. This is the post action, and here is the loop that accepts files. I would have some tiny complaints about having the ignore list in two places. Now, this is technical issue, really. That also tells us that both models in Claude Code are lacking the depth of analysis. They do not think the way we humans do. So in the end, while Opus did do a very good job about what I asked, it completely failed on everything I didn't ask for, but should be a part of the development culture, the experience of a senior developer. That part is completely missing. It would be interesting to see how Claude Code will develop, and will these deficiencies eventually somehow be overcome? That is a very interesting question. I would like to see how that develops in the future.